Here we are in section 3.2, and here we're going to be looking at the graphs of functions and how we can determine certain things from them directly. And we begin with quite a group of problems. Actually, there's only two examples, but what we are trying to do is we are trying to answer many different questions about the same thing. First thing we need to do is to determine whether the graph is that of a function. And what we do here is we use a vertical line test. The vertical line test says if at any point along the graph a vertical line, which is a line going up and down, if it hits the graph in more than one place, then it is not a function. And this can be at one place, it can be at infinitely many places, or it can be at any number. But if it happens even once, then we know we do not have a function. And so if we look at number one, all vertical lines, if we start from the very far left and go all the way to the right where it ends, it only hits the graph once. And so, yes, this is a function. Now, if it is, we're going to use the graph to find the domain and the range, the intercepts, and any symmetry, if there's any. So the domain here, in other words, what values are the graph, the x values. Domain basically is the x values, and we start at negative pi, and we go all the way until pi. And by looking at the filled in circles there at the end, that means negative pi and pi are included as well. And so we do have that as a potential, or those are values that are allowed as well. Now the range, we're looking at the y values, and I look at the absolute smallest value for y and I get a -1, and the absolute positive, the highest value, is +1. And once again I ask, does it actually have the value of -1? The answer is yes. And does it actually have the value of 1? And that answer is yes as well. Now it asks for the intercepts. In other words, where does it cross any one of the axes? Well, the first place it crosses is at -pi 0. Then it crosses at 0, 0. And then it crosses at pi 0. Those are the three places it crosses the x-axis, and the only place it crosses the y-axis is at 0, 0. We will not list that one again, and basically we are done. Then finally we need to look at symmetry. And symmetry can either be x-axis, y-axis, or origin. Now x-axis, in other words, if we would fold the top onto the bottom, would it lie on top of itself? The answer here obviously is no. Y-axis, if we take the left side and try and fold it onto the right side, we ask, does it lie on top of itself? And that answer is no. Finally, the origin, if we take any point on the graph, go through the origin and go in the exact opposite direction, that exact same distance, do we end up with the same, or do we end up back on the graph? And here is a case where the answer is yes. It does lie on top of itself, and so we have origin symmetry. Example number 2. The vertical line test looks really good up until the point we hit x equals 8. X equals 8, it has both the value of -7 and +8 because of those filled in circles. And so no, this is not a function. And so as a result, generally we would have to say, you know, we don't need to do the domain, the range, and the intercepts, and we don't have to worry about the symmetry. But for completion, I do want to do that. So we're going to do the domain, the range, the intercepts, and the possible symmetry. Domain, I look at, okay, the domain, the x values It appears to go on forever in all directions, so the domain would go from negative infinity to a positive infinity. There's no value that we have to exclude, and we're not bounded at the ends. And how do we know that? Because on the graph there's no point at the far left or the far right. It just trails off, which means it is implied to go on forever and ever. Now the range, there's only two values that we have: -7 or a +8. Those are the only two values that show up on this graph. And we have to assume that it's going to go off in the same direction to the left as well as to the right. So our range would be -7 and 8. The only place it seems to cross the axis is at the point 0, -7. And then as far as symmetry goes, if we try to fold the top on top of the bottom, it does not line up. We try to do the left and the right, that doesn't line up exactly either. And then even the point, say 0, -7, if we were going through the origin, that would be 7, 0 or 0, 7, and we don't have that situation either. So there is no symmetry whatsoever on this particular graph. Now the next group of problems just ask some general questions, and we just have to look at the equation or the graph and go with that. We're asked, is f of 6 positive or negative? Well, f of 6, the 6 means we have to go to where x is equal to 6. So if we go to where x equals 6 and look at the graph appears to be the point 6, -4. Once again, that's the point 6, -4. And so we're asking, is that positive or negative? Well, obviously, if I said -4, then that means we are looking at a negative value. Example number 4. What is the domain of f? In other words, what x values can we plug in? And since there are solid points at the ends, that means they stop. They do not go on forever. And so as a result, it appears to me the x value starts at -50 and it goes all the way up until +50. My only question is, do they include those particular values? Well, since the point is filled in, -50 is included as well as the +50. And so that would be the domain for example number 4. Example number 5, it asks, how often does the line y equal 20 intersect the graph? Well, y equals 20 is the horizontal line going where that first mark is. And I know that because I have 5 marks leading to 100, and so every mark would represent 20. So if I just do the line y equals 20, which is the horizontal line, I see that it crosses the graph at 3 different locations. And so that's what number 5 is asking. Just very roughly, I will show what that one's going to look like. We get something that looks like this. And here's the y equals 20 line. And there's the 3 times that it appears to be crossing. And then the last group of problems simply asks us to answer questions, general questions about the particular functions. So number 6, we're given the function f of x is equal to 2x squared plus 4x plus 9. Now, if x equals -1, what is f of x? Well, simply, we need f of -1, which goes back to the last section. This should not be a great surprise. So 2 times -1 squared plus 4 times -1 plus 9 equals 2 times 1 minus 4 plus 9 equals 2 minus 4 plus 9 equals 7. And so to answer the question, what is f of x? That is 7. Then it asks, what point is on the graph? Well, I've got an x value. My x value is -1, and the corresponding y value whenever I plug in -1 is 7. And so -1, 7 would be a point on that particular graph. Example number 7. We are given the function f of x equals x squared minus 2 over x plus 3. And we're asked, is the point 2/5, is that on the graph? Well, we're asking if we plug in x2 for x, do we get 2/5? So, let's find out what f of 2 is. F of 2 would be 2 squared minus 2 all over 2 plus 3. 4 minus 2 over 5. 2/5. So, if x equals 2, the y value is 2/5, and therefore, does this point show up? Yes, it does. And that is the answer for that problem. And finally, example number 8. F of x equals x squared plus 8 all over x plus 4. We need to list the x-intercepts, if any. Well, x-intercepts means the y value is equal to 0. So in other words, we need to let f of x equal 0. So we get this particular problem. Now solving for x, first thing we're going to do is multiply both sides by x plus 4. So we get x squared plus 8 equals 0. Subtract 8 from both sides. X squared equals -8. And when we attempt to take the square root of both sides, we notice that we go into imaginary numbers, and so there's no solution for this particular problem. As a result, are there any x-intercepts? The answer is no. Nowhere does y equal 0. We have shown that algebraically by plugging in the values and then attempting to solve.